Okay, next part is very important, which is called isomer counting. So first, I want to introduce a very important concept, which is called DBE, double bond equivalence. We can also say unsaturated degree or electron deficient index. All of those are the same. Pretty much the idea is kind of how many pair of hydrogens is lack of compared to the saturated normal alkane with the same number of carbon. So here, if we have something like this, a formula, can you show what is the formula to calculate the DBE? So we know if we have n carbon, it's supposed to have 2n plus 2 hydrogens, right? Because this is the number of the hydrogens when it's saturated. So we use this minus the hydrogens we have right now. We use this to minus the halogens we have right now. Why? Because the halogens are always replacing the hydrogens, right? And then divided by 2. Why we don't care about the number of the oxygens? Yeah, the oxygens either is single bonded to a carbon. Let's say the oxygen is either in this way inserted into a CH bond. So it doesn't matter, it's something in between. Or is inserted into a carbon-carbon bond. The first case will make it into an alcohol. The second case will make it into an ether, but they will not change the number of the hydrogens, the number of the carbons. There is also another way it will bind with a carbon with a double bond, right? How about this case? If this is the case, it's a kind of replacing 2 hydrogens, which means it will affect the hydrogen numbers, and then the hydrogen numbers is already a reflection of the CO double bond. So we don't need to worry about how many oxygens in the molecule. The hydrogen numbers is already, a good reflection of whether the oxygen is a single bond or a double bond. So basically, a ring or a double bond has 1 dBe, a triple bond is 2 dBe. So our strategy when you have a formula is first, you list all of the possible function groups based on the dBe. I have an example here. For example, carbon 3, hydrogen 8, oxygen 1. So you calculate dBe is 0, so which means you can only have either a OH or a ether, right? Which means you cannot have any CO double bond. So this is very important. You need to work on the dBe first. And then if you have a molecule like this, after you do the calculation, the dBe is 1. So all of the possible function group combinations are a CO double bond, which means either aldehyde or a ketone, a CC double bond plus a alcohol, a ring plus a alcohol, a cis double bond plus a ether, or a ring plus a ether. So those are all of the combinations, right? So if we want to try this, let's try it. So first, if it's a CO double bond, how many isomers we can get? We can get an aldehyde. Do we have more aldehyde? We can get a ketone. So we can only have 2, no more, right? If it's a CC double bond with a OH, basically we just need to add the OH in different positions. So we can put it here, we can put it here, we can put it here. If we don't consider which position is stable or not, okay? Not just count. Although we got 2 enols, right? Let's do not count about the enos right now. Although we know enos are not stable, we just count how many isomers. If we got a ring, which means it's like this, right? This is the only case. And you may also need to think about whether we have the stereoisomers or not. Three-membered ring is unstable, but it is existed, okay? It is existed. And then we can also think about the CC double bond with the ether. So which means we have to put the oxygen here. This is the only place we can input the oxygen. There's no other place, right? The last thing is the ring plus ether. If it's the ring plus ether, if you have the three-membered ring, we cannot put into an ether, right? So we can do a three-membered ring with the oxygen in between and something like this. We can also have something like this, a four-membered ring. So yeah, now we consider the case you mentioned. So this one is okay. How about this one? Is this one chiral or achiral? So you will see this carbon is chiral because this carbon connected to four different groups. A methyl group, a hydrogen, something like this, something like this. They are different, right? So it's chiral, so we need to multiply by 2. So basically, we consider all of the possible situations, right? By going through all of the function group combinations. And then we start to determine all of the carbon skeletons. This is called skeletal isomers. For example, C5H12, I think it's pretty much easier for us to figure out what are all of the skeletals, right? We got 3. We are trying to decrease the number of carbon on the main chain from 5 to 4 to 3. And we try to add more branches to the major chain, right? And then we determine all of the unique positions of the function groups on each unique carbon skeleton by adding either the alcohol or inserting the oxygen, which turns into an ether. This is called positional isomers. For example, can you guys try this example and let me know how many molecules, how many isomers you can get? You may need to consider the stereoisomers as well. Yes, a good point. DBE 0, which means it's either an alcohol or a ether. You guys can try it by yourself. I will try it by myself. Yeah, I'm done. I got 8. So based on my note, can you figure out what is my strategies? First, I divide into 2 function groups, alcohol or ether. And then I consider the skeleton, so I can got 2 different skeletons. And then I consider the positions of the function groups. So if you need to add a OH on the left skeleton, you only have 2 different cases, right? One here and one here. And then if you have the right skeleton, you also have one here, another one here. So you got 4 from the left side. Let's count the stereoisomers in the final. And then if you have an ether, you also have 2 skeletons, but you need to insert a oxygen in between 2 carbons. So you can put it here, you can put it here, right? That's it, right? You got 2. And if it's here, you can only put it here because these 3, they are symmetric. Do I? Dimethyl ester? Because there are 4. I don't think I have anything repeated. Because here, think about, one is like this, another one is like this. Obviously, they are different, right? And the right one is even more different than this one, right? So those 3, they are different. They are all different. My leftmost, oh, this just means I want to draw the ether, okay? It's not a dimethyl ether. I just want to use the symbol to show I want to draw all of the ether isomers. And then finally, you think about the stereoisomers. So you will see only this one will have a chiral carbon. So you will have a stereoisomer, and all of the others, we don't have any stereoisomers. So there are 8 in total. So you will see it's not a very complicated formula, but you got a lot of isomers if you consider all of the cases. Okay, let's try to finish this part. So probably we need to use a few more minutes, okay? Yeah, the +1 here, which means there is a stereoisomer. There is one, isomer with a stereoisomer. So this is why I +1 there. Okay, next, let's try this. Can you try it by yourself to draw all of the isomers of the carbon 4, hydrogen 8? Yeah, considering the stereoisomers. Or how do I count the stereoisomer? You go through the structure one by one, and you quickly figure out which one has a chiral carbon. So obviously, all of those ethers, they don't have stereoisomers, so you have a limited option. Do you list all of them? This one, we don't. This one, we don't, right? So only this one will have the stereoisomer. Okay, you guys already start to work on the next one. Let me try. Oh, we got 7. Let me try. Oh yeah, I forgot one. Sorry guys. My bad. Is this chiral? Okay. I think there are 6. So let me show my strategy. First, you calculate dBE, but this time no one reminds us the dBE is 1. So basically, you think about the functional group, a alkene or a ring, this is the first thing you should do. Otherwise, the more time you emphasize on the other stuff, the easier you'll forget the rings, right? So this is why I ask you to calculate PPE first, no matter how easy, how simple the molecule is. And then I think about the skeleton. Actually, I didn't, I forgot, because I think it's too easy, right? So I made the same mistake. I should think about the skeleton first. So I got two different types of skeletons. And then I think about the position of the function groups, right? I put the function group here, put it here, and then when I put it here, I know there is cis and trans. So I multiply by 2. And then if the skeleton is like this, I only got 1. And if with the ring, I have the 3, remember the ring? I have the 4, remember the ring? The 4, remember the ring? And then, obviously, this is a achiral carbon. So the final result is 6. I think you guys definitely need to have a little bit more practice. So I prepared a few for you guys. Obviously, we cannot finish all of them. Can we try D? And also try F. Let's finish these 2 questions, okay? And C, if you can. Michael, let me try. I will double check my answer. Let's start from D, okay? D is the most difficult. Yeah, we always consider stereoisomers. This one is chiral, one methyl propyl amine. Let me try. Wow, you are right. Good point. Yes, this one is chiral. So there are 9 in total. Wonderful. Okay, guys, let's finish D and then we will end the class today, okay? So then briefly introduce my strategy. So I kind of use primary, secondary, and tertiary as my guidance. But my first step is calculate DPE. For a molecule with nitrogen, we need to use a slight different strategy to calculate DPE, because we can always think about a nitrogen equals to a CH. So this is why I add one more carbon, and then I also add one hydrogen. And then I calculate the DPE 0, which means it's fully saturated. And then I think about all of the skeletons. So we have two different types of skeletons. And then I try to think about the different positions of the function group. If it's a primary amine, which means we have an NH2 group, needs to be connected to a certain place. So I can connect here, NH2 here. I can connect NH2 here, so I got 2. If we do not consider the stereoisomers. And for this skeleton, I also have 2 different cases, right? So I got 2. And if it's a secondary amine, I need to put an NH in between 2 carbons, which is like an ether. So I also start from the 2 skeletons. So I can input in between these 2 carbons. I can also put in between these 2 carbons. So I got 2. And if I have this skeleton, I only got 1. And for the tertiary, we need to have a nitrogen which connects to 3 carbons. So this is the only case. So if we do not consider stereoisomers, we got 8. But reminded by Michael, we realize this one is chiral. Actually, I missed this one. So we got 9 in total. Sorry about the wrong answer, but I'm pretty much sure about all of the others should be correct. But in case I got anything wrong, you can always remind me. Isn't the secondary ones the same? Or why they're the same? Which 2 are the same? I don't think they are the same, because they have different skeletons. Would you have E and Z isomers on the secondary amine if the N was in the middle? Because there's no double bond. If there's no double bond, you don't have EZ isomers, right? You don't have trans and cis, because all of them are single bond. Single bonds are freely rotated. Let me see Ella's question. The one where you substitute nitrogen to make a secondary amine, there is not stereoisomers. Do you mean Miss Jordan? One is like this. Another one like this. Another one like this. So which carbon is chiral? Okay, I don't think there is any chiral carbon. Okay. Did I answer all of your questions? For part C, 6 cyclical alkynes. Let me try. The DPE is 1. So we can start from this. We can start from this. We can have this. We can have this. And this, we need to multiply by 2 because we have the cis and the trans. That's it. Oh, we got 5. Ooh. Did I miss one? Yeah, I got 5. This one. The 2 methyl groups, they can be in the same side. They can be in a different side, right? Oh, by the way, wait a second. I got more. Because this molecule is chiral. Yeah. Wow, thanks for your reminding. Obviously, C is quite complicated. Okay, guys, I know you guys have a lot of questions. Take it easy. Slow down. Just do more practice after class, and then we definitely got time to discuss those questions next class. And I will also post, my annotations in the Google Classroom. So we already extended for 15 minutes. I hope I will not affect your schedule tonight. So let's stop here and we will see you tomorrow night.